questions. What do you got? Whoop. Hey guys, so my name's Scott Brink, and I'll get to that actually later. Tool Talk is on MobileSF. It's a tool called Mobile Security Framework to analyze mobile applications. We'll get to that later. So, who am I? I've introduced myself like 3 times today. Fourth year CSEC. I worked for IBM as a pen tester over the summer. I'm on the swim team here, tech lead for RITSEC, and I'm a meme connoisseur. Send me your best memes on Workplace. So, what's a MobileSF? Like I said before, MobileSF is something called Mobile Security Framework, and it can do a lot of cool things, and we're going to get into that. So, what are you even analyzing? Like, why would you use this? You're analyzing the code of the applications. So, we'll actually talk about IPAs first. IPAs are iPhone applications for iOS devices. It doesn't really analyze it as well as it does for Android. So mainly this is going to be focused on Android. So Android, these are Android packet kits. What that is, it is a zipped archive of all of the compiled code. And luckily, you can decompile it and get a lot of cool things. So now we're going to do a live demo of this. So hopefully the demo gods are kind to me. And it's not there. So we'll go to GitHub first. So here's GitHub. And so it's completely open source. And it can tell you a lot of stuff you can do here. So you can do static analysis, meaning just looking at the code. And we'll be doing that. I already put an application into it. Some static analysis of the IPA. And even some Windows apps. This is new. They keep updating this like very recently. You can do some dynamic analysis. I haven't messed with that at all. And so let's take a look at it. If you want to run it, there's some documentation you can go to. Let's do it live. You can download a bunch of stuff, but that's annoying to do. Luckily, they have a Docker instance. And I'm not going to explain what Docker is. That will probably be another tool talk at some point. But right now, I have it running right now. And if we look, what you do is you feed it the APK and interesting. There we go. Cool. Okay, so the demo gods like me. So I already fed APK. It takes a while to analyze, so I was doing that before I got up here. This is, yeah, an 18 meg APK. So if you look through this, it analyzes through, it reads the signature, it goes through one of the configuration files called the manifest, the Android manifest, and it'll go through all the permissions. So it'll see this app needs your camera, your course location, find location, internet, a lot of cool stuff there. Does some binary analysis, and then it separates up a lot of different stuff. So this is when it's inter-process communication here. A lot of cool things. A lot of applications have issues with hard-coded information. So if we look here, we look in their manifest file. I've already opened it up here. This isn't necessarily a bad thing, but if we look, they have their API keys right here for some other stuff. I know of certain applications that have hard-coded passwords, hard-coded OAuth credentials. I'm not going to show them on stream just so we don't stream out vulnerabilities in an application, but there's a lot of really cool stuff you can find on this, and it's super easy to use. How do I zoom in? Oh, like that. All you would need to do, install Docker and do this, Docker pull that. It will download everything, and then run this command, Docker run, and then that will have, let's do this. So all you would do is you upload, where is it? It's in my downloads. You would give it an APK like that, and it's already analyzed that once. That's why it loaded so fast, but it usually take a while. And there's a lot you can do. You can look at pretty much all the Java code. Sometimes they can obfuscate this code, so you won't be able to see it exactly. Like if you look at some of this, it's wherever it is, variable 5-5, 6-6. So you can't get everything from it when you're decompiling it, but you can get a lot of cool stuff. And using this tool over the summer, I was looking at some mobile applications, and I found, I think like I tested 7 applications, and 5 of them had like really sensitive data stored in plain text. So get some APKs. You can kind of just like pull. You can actually pull the APKs from an Android emulator. If you want to talk about setting up an Android emulator, just come talk to me later. And there's a lot of cool stuff you can do with it. So yeah, that's about it. Tool talks are usually just small introductions to tools, not telling you everything you can do with it, but just getting you introduced to it. Go play with it. Go download some APKs and see what you can find. Oh yeah, questions.
Where'd you find this thing?
I found this in Rob Olson's mobile device security and forensics class.
I wasn't even trying to pitch that. That's
yeah,
awesome.
It's actually a really good class.
Wow, sponsored.
Yeah.
Okay, sponsored.
Sponsored by the Center for Cybersecurity.
Responsible disclosure. Cool.
All right. So now what we got going on is a talk about perimeterless devices, BeyondCorp. A lot of big words. What's going on? No, but we have a dongle for you. Yes. Yes. Okay. So yeah. I'll let him present on it. I'm not going to present on it. The only thing I can say more would be presenting on it. So you go.
What? Not well. Hold on. That look better? Is that like readable for everybody?
Yeah.
Cool. All right. So what Nick has been trying to say for like the past 3 times he tried to announce it is I'm going to talk about BeyondCorp and device-based trust, which is basically just a way to do okay, it's hard. Okay, fine. Perimeterless network security. So real quick, who am I? I'm almost an alum, pretty much any day now. I already graduated, I think. That's kind of getting finalized right now, but I'm here hanging out because it's cool. And I miss the people, and it's a lot of fun, and it's cool to see new faces and see what you guys are going to do. So super excited for you guys and like your new year. I'm going to be a security engineer at Facebook over in California, so that's really exciting. I do corporate security over that way. What else did I do? Last year I was a competition architect for ISTS, which was tons of work and tons of fun. If you guys don't know anything about ISTS, I'm sure you'll hear about it, and I recommend it 100%. Captain CCDC last year, which was awesome. Also highly recommend that. I think Tony's still in the back, so talk to him about when that's going to start. I'm sure there'll be announcements. And then I've kind of been on red teams for different competitions as well. I did Lockdown and RITSEC as well, so that's pretty much what I do. Aside from that, I'm interested in building things. I really like dev work and just trying to build new cool security tools. Both red team and blue team, I kind of try and be on both sides of that fence overall. And then I'm interested in infrastructure security, which is pretty much what this talk is about. So if I say the word infrastructure security and you really don't know what that means, this is a good way to look at it, I guess, is like this type of thing. And then I dabble in AppSec a little bit. Outside of security, that's why the cricket is there. Cool. Normally, I'd give this other talk at the first meeting. I think I've done this one like 3 times now. So I usually give the how to get free shit stuff. But because I'm not giving that this one, I give a link to the last year's presentation. So if you're like in college and tuition's a lot and you just don't want to pay a lot of money for things, that is how you do it. That's how I got by, and that's how a lot of people get a lot of free stuff, because RIT gives you a ton of resources, most of which I think we listed out in that presentation. So go check that out. So we're going to talk about a problem today with traditional network design and, like, I guess just assumptions for security that aren't valid anymore, right? Like, that's the theme. So we're going to talk about networks back in the day, right? Like when all this came about, when security was starting to become a thing and whatnot, we'd have a good old Corp network, right? And that was cool. We'd have some, modern devices with modern hub networking equipment and maybe a Cisco router. And then we'd have prod, where we were like, okay, well, we have to make money off of this somehow. So I guess we have like a bleeding edge, like high performance database as well as a web server. And we're like, cool, well, I guess we can make money off of something. So we made an awesome website, and we're like, wow, this is exciting. And then we're like, well, it'd be cool if we really developed this website a little bit faster. So we started hosting some internal tools that are also cutting edge because, startup culture in the .com bubble. So we're like, Subversion, Jira is what's up. Ben, question.
So as your friend, I want to make sure, okay, you say Oracle's a high-performance database.
Oh, for sure. It's probably the highest performance, I think, overall.
Do you need help?
Yes. I'm being paid to say that. Okay, so this is like the general setup of companies like a while ago, right? And then they'd realize, whoa, I'm on the internet now. I mean, it wasn't that cool back then, but, you know, it was there. And you had like Internet Explorer 6 or something like that. So you could like poke around and all the nerds were like, this is awesome. And all the other people were like, what the hell is the internet? So that's kind of like the environment that we were in. And then you had these hackers that were like, wow, you put your database on the internet. Noob, this is awesome. So they're just like attacking databases all day because they're just publicly available. And then we were like, oh, I know what to do. I know exactly how to solve this problem. I'm not going to like secure the database or anything. I'm just going to not let you talk to it, right? So this is where like the idea of a DMZ came out, right? So DMZ is basically a demilitarized zone, which is really common in like a lot of like network security postures. The gist of it is like this is like the network that all of your publicly facing services are in, right? And then everything else should not be able to be talked to from the public internet. And that was the idea, and it worked for like a pretty long time. You basically just put your web servers out there, and then really your main attack vector was either you had to worry about people popping your website, so if there's like vulnerabilities in your website or third-party dependencies, you'd have to worry about that stuff, and you'd also have to worry about people like clicking on wrong emails and stuff like that. But overall, like it was a pretty good security posture. Basically, the way that it views things is that anything inside of the DMZ was trusted, and so you were kind of allowed to like go wherever you want and like access a bunch of different things, and like your trust level is pretty much associated with like what network you are on, right? So like that's what ACLs do, is they pretty much just like define what networks are allowed to talk to what other networks, right? And they try and like build security in that way. And then if you're outside the DMZ, of course, you're just untrusted and you can't access anything. But now we're in current year 2018, where things look a little bit differently now in our entire like corporate setup, right? Companies structure things a little bit differently now. And now we're going to talk about that. So what changed? Well, we've got Corp, right? It's a little bit smaller, but it's actually not smaller. I just had to fit more things on the screen. So we got laptops and phones, which are pretty cool. Phones came about, and now we can use them for tons of different things in case like I go to the bathroom but want to keep working for some reason. Then we got the internet. Wow, that's awesome. Like we got like Instagram now and Google Chrome. Like we're really blazing through. So I guess we better make some money off of that. So we're gonna, have a prod again. And what do we do in prod? Well, I mean, we know that we need a DMZ, so we set that up, and then obviously we use Docker for our web servers up there because that's the best way to go. And then we'll just put a firewall in front of that and call it a day for the most part. So now we have a secure business running some website, and that's scalable, obviously. But now it's scalable because now we have Mongo and Elastic to use, which are really cool because they are very secure and they're super fast and high performance web scale. Now we need some dev tools again, which would be like Travis and Git, all the things that we need to keep pushing out new updates for our code. And the term is hashtag increased developer velocity. So if you haven't heard that yet, good for you, but now you know. So after we're done, increasing some developer velocity, we'll be like, wow. Click it. Oh, yeah, now we need container orchestration, which means we need Docker Swarm. That just lets us be more scalable by like automatically spinning up new containers and down new containers, and we'll just kind of throw some shit over there, and it'll be over there. It's pretty great. And then we have clouds, right? Like that's a new thing. So we have to use the cloud because that's like where everything's at these days, and it's so much easier, especially if we want to like, add machine learning to our like shopping system. That'd be, standard these days. So we have to do that. And then we've got a Q&A to like test it all, right? Now that we're getting like a little bit bigger, we need to be able to verify things before we push them out. So we'll just, use prediction data in this less secure network, and we'll just call it a day. Like that sounds good. And then on top of that, maybe we have data centers now. Maybe we're really growing. Or maybe we got some other offices if we're not quite to the data center level yet. Or maybe we've just got our remote worker named Jim. Jim just is like some dude in Colorado, but we're like, you know what? You're cool, Jim. Let's work here. And so, to let Jim work on different things because we have, network-based security. He wouldn't be able to do anything from outside of the DMZ, right? So we have to bring him in, so we have to use the VPN. And as you guys can see, like there's a lot of problems that are coming up, right? It's not the same traditional network design that we've been using. And so this perimeter security model that a lot of people implemented, I think is broken. Basically what happened, as you guys saw, is technology exploded, like way faster than anyone thought. And I mean, it's hard to predict these things because we're always like, oh, in 10 years we're going to be way far ahead. And then we're like exponentially farther ahead of that. So that's kind of what's going on. And when that happens, like the attack surface like explodes. right? Like it's a lot harder to manage security these days because there's just so much going on. There's so many like different mobile apps, or you've got like dev servers and all this other garbage that it's like hard to like actually secure, right? So it's like impossible pretty much to prevent yourself from getting popped. Like that isn't how you can structure security anymore, right? You can't go on the assumption that you haven't been hacked yet. And also, physical barriers aren't much of a thing anymore. Back in the traditional model, you used to be able to be in the same building, right? Like everyone was just in an office, you know, like somewhere. And that's where all the networking stuff was, and they would just host everything there, and then if you were inside the building, that was cool. But these days, that's not even close to true. Like, how many people here have like worked remotely or done anything remote at all? Like, it's becoming like super popular, right? And then there's like companies with tons of offices, and now we got like data center stuff going on that's pretty crazy. So physical location is like not really something that we can rely on anymore for our workforce. Which basically leads to the conclusion. We can't trust network perimeters anymore because we can't rely on them for security. Like they're too easy to be infiltrated, and once someone's inside, usually networks are like Swiss cheese, man. You just like pop something and you're like, wow, this is great, and you pivot around, then all of a sudden you have like production database credentials and you're just stealing credit cards and all that stuff. And that's what we're trying to prevent, right? So the whole goal of this talk is to move away from network perimeters as a dependency for security. And this kind of started back in 2011, actually, when Google started implementing this. They came up with this idea called BeyondCorp, right? And they released a white paper about it in 2014 talking about their success and how this is what they were going to do, and this is like the best model. And they were like, you know what? Fuck it. We're just going to take our network and make it public because that's the best way. We're just going to take all of our services that are internal and just like put them on the public network, and we're going to have public DNS records for them so that we can just easily get to them. And that makes a lot of sense, right? And all of you are just like dumbfounded right now. You're like, what? How does it make any sense? Didn't we come from the area where databases being on the public internet were a bad idea? Right? Like, this doesn't make any sense. And the answer to that is yes, that does sound like a bad idea. But pretty much what we're going to do is we're going to gate the access to those things, right? Like per service. Instead of per network, we're going to go to per device, and we'll talk about that in a little bit. So basically, the whole goal of this is to allow workers to connect without a VPN and to secure things without relying on network security, right? Well, I mean, you have network security, but not relying on what network you're on for security. And we're going to talk about the more complex authentication, really some of the really cool shit that you can do with this. So far, any questions? Because now we're going to start diving a little bit. Everyone up to speed? Everyone good? Cool. All right, here we go. So, device-based trust, right? This is like the first component to BeyondCorp and how it all works. Basically, what we do is instead of restricting what networks can talk to services, we do it by device. And the way we do that is basically we issue each device a certificate, which basically identifies the device that you're on, and then we use the certificate to access different services, right? So not anyone on the public internet can access your services, only trusted devices with the right certificate. And the certificate has to be stored somewhere safe, like a hardware TPM, and if people are looking for cool-ass presentations to give, look into TPMs. They're really complex, and they're really cool. So I think that is somewhere to go from here. Basically, what a TPM is, it's the Trusted Platform Module, I think. I don't know, there's too many acronyms, so whatever. Basically, what it does is it like holds certificates or other cryptographic keys for you in a private manner. So basically, you just push certificates or cryptographic keys or things like passwords, I guess, into the TPM, and then you can't read them from the TPM, right? All you can do is say, hey, I have like this web request. Can you sign it for me, right? So you pass that to the TPM. TPM signs it for you and gives it back. That way you don't know, like there's no way to read the information from, you can't read the certificate from the TPM. And the reason that's really important is because ideally that prevents like the certs from being copied or stolen, right? Because that way people could like breach the device-based trust model. And there's some really interesting threat vectors with TPMs and all that stuff, but we're not going to get into that too much today. So we got to manage certificates too. Basically what we do is anytime a new employee is registered, like I'm onboarding, whatnot, you have to provision their laptop anyway usually. You're like, okay, well what we're going to do is we're going to put all the dev tools that you need on there for developer velocity, obviously. Like, I don't know, Slack and Git and, you know, all those cool things, maybe an IDE or two, and, you know, our security tools and whatnot. So when you're doing that, you basically just put the cert on there, right? Like you issue the device a certificate and you put in the TPM. And then the cool thing about this is anytime you want to cut off access for a device to the network, all you have to do is revoke the certificate. That's kind of how it works, right? So we'll talk more about that in a little bit, but the idea is like those certificates are only valid because we say they're valid, like from a central point of authority. Right? And so we'll talk a little bit more about how that all works in a second. So let's talk about the device database for a second. This is like the second core component to how BeyondCorp works. Basically, we have a device database that just tracks all of that stuff we just said. So all the devices, basically, we just associate with a database. And we're like, this device has this certificate, right? And then what we do, really cool, good idea, is we take all of our security information and we associate it with the device. This makes sense, right? Like you're like, okay, I have like some carbon black endpoint stuff running on the device, so I might as well put that in the device database. So I can get all of the output from like the security tools into the device database. So that way it's very easy to see all relevant security information from the device. Now, some of you are probably thinking, you're like, huh, it'd be kind of neat if we had the ability to see if a device was secure or not before they connected to some services. So I'm gonna hold you there. Don't jump there yet. So we have the user DB too, right? This is the other component. So we got devices and we got users, and basically the user DB is just your standard HR portal thing that just holds some information about users, like the devices they own, or the job title or position, or maybe their team, or their normal operating hours, like whatever you think that might be useful to know about your user, probably for other purposes even. Like this isn't really specific to BeyondCorp, but this is just something that we need. And the other thing is like what permissions the user is able to have, right? Like are they able to access this service or not? Like some kind of like service checking like ACL stuff, right? Which we'll get to in a little bit. And this is where it all comes together. The access control engine, right? This is like the whole, like, I guess, meat of the potatoes here, or whatever that phrase is. Basically what we have, right, is some kind of engine that lets us approve or deny every request coming into our services. And that sounds cool, because what we can do is we can pull the data from the device DB and from the user DB, and correlate that to a request, right? So a request comes in, and I'll explain that in a second, actually. But what this lets us do, keep this in mind while I talk about this, right? Because you're like, whoa, that's awesome. We got like each service can have its own access control rules. So basically what we can do is we can more fine-grain access restrictions on services. Instead of just like saying anyone from this network can connect to the service, now it's anyone on this device with this user can connect to the service, right? And also, you can use this to approve or deny access to specific resources on this service, right? So think about GitHub. Everyone here know what GitHub is, or should I use some of the different hand raised? No one knows what it is. Wow, okay, that's embarrassing. Cool. Like most people understand what it is. Cool. So basically think of it as like, if I put this in front of GitHub, only your user can update to your repositories, but everyone can read them, right? That would be like an example of how you can restrict specific resources for a service. So we're just going to go through a little bit demo. I have a lot of animations because I spent a lot of time on the animation part, so I was like, this is cool. So here we go. So basically, we send our HTTPS request with our device certificate, the user SSO token, which we'll get to in a second, and the resource that was requested, right? So like, imagine I'm trying to go to Kyle's awesome red team repository on GitHub. Then the access control engine's like, all right, well, thanks for your certificate. Let's go check it against the device database and pull all the security information, et cetera, from the device database. Then we take the user's like SSO token, which we'll talk about in a second, and we get all the information from the user, right? Basically, what you need to understand, if you don't know what SSO is or what certs are even, don't even worry about that. The whole point here is that the access control engine, this like little service we've got going on, can get all of the information from the device that's trying to connect and the user that's being connected with, right? And with that, we can write what's called a service ACL, which is basically like the list of restrictions on who can use this service and who can do what on this service, right? And so like an example I gave, right, would be like, well, if you want to connect to our internal code repo, you have to be a full-time engineer, right? So we have require employment full-time, require position engineer. But also what's interesting is we can say, hey, you know what? I want to make sure your device is like in good security standing. So like, let's imagine we had some kind of scoring algorithm, took all of our data from all of our like security endpoint tools, and kind of like detected like, how likely is it that this device is compromised or hacked, right? And if it's above 95% that it's not hacked, right? Like if we're 95% confident that this device looks okay, then it gets passed. Otherwise, we send the user a message saying, hey, your device isn't looking so hot, so we're not going to let you use the service, but maybe you should talk to security about your device and like report an issue, right? The next thing that's cool is we can also say no devices like with any known vulnerabilities can access this, right? Because that's a lot of risk. So if you've got a bunch of client endpoints and all of a sudden there's this new OSX Bluetooth O-Day that's coming out, and you're like, holy shit, like all of our devices are going to get like RCE, so it's going to be a mess, right? Like it's going to take us a while to get the patches out to the people that are working out of Nicaragua. So we should basically have something in place that says if there's any known vulnerabilities on this device, don't let it connect because we don't trust it. And also, like, maybe it's good to verify that the device that is connecting is in the same place that we expect it to be, right? Like, we expect, you know, Jim to be working from Colorado. So if he's connecting from, like, I don't know, Albania, it'd be pretty weird. So it's good to verify that. And then this next part is an example of how we can basically specify, like, specific, like, actions or resources can be controlled even more fine-grained. So only people on Team A can update repositories in this model, right? Is everyone with me so far? Does that make a lot of sense? Cool. And basically what happens is the scoring engine, or the access control engine, right, basically takes all of those things and is like, oh, yep, this matches or no, it doesn't, for each service, right? And it does this on every request, which is really cool. So basically, like, every time you connect to the service, it's doing this check for you to make sure that everything's good. So the best I can do is an example. I wish I had a demo for you guys, like all the rest of them, but that was really not a thing that I can set up in a short amount of time, because it's kind of complex stuff. So we're just going to go through a nice little animated demo of how this might look. So we've got Jim sitting in Colorado at a Starbucks maybe, and he's on his sweet new managed device, and that's cool. He's got his work phone, obviously, because, you know, in case, you know, the boss calls or whatever. And he wants to get to this internal code service. So what we call Jim is a high-impact developer, and he needs to contribute some code. Like, it's like 4 a.m. maybe, and Jim's really cranking out stuff, and we don't want to impact his developer velocity at all. So we're like, you know what, Jim, just for you, you don't need a VPN. You can just connect. And Jim's like, oh, that's good. I don't have to waste my time with that security stuff anymore. That's cool. So Jim's like, all right, let me just try connecting. And all of a sudden, well, it goes to this access proxy, which is what the domain for the service points to, right? So if we had like some cool site, we'd be at code.coolsite.com would be where we'd point the DNS record to for the internal code service, right? And the access proxy is like, Jim, actually, it's like, who are you, right? So it redirects you to SSO. Because what Jim didn't do is send a single sign-on token, which means Jim hasn't authenticated yet. So basically what happens is we have some kind of single sign-on service. You can think of like AD or one login or something like that. People, how many people know what like SSO is? Or do you want to go into that a little bit? So we're okay mostly? All right, think about it as like just an authentication service, right? Basically, it takes a username and password, and it logs someone in. So Jim supplies his username and password, but it's been a while, so he might miss a couple attempts, but eventually he gets it. And then the single sign-on service connects to the user DB, and he's like, all right, well, what's this guy's 2FA mechanism? And apparently it's his phone, so the auth service sends a 2FA push to Jim's phone. And Jim's like, fine, I'll bring out my phone. It's all the way on the other side of the house maybe. Clicks the button finally. And he accepts the 2FA, and that's cool. Now we're like, all right, you're a trusted guy. We know this is your right account. Here's your SSO token. And Jim's like, finally, God. Oh, it took so long. So he sends his request with the device certificate and the SSO token. Now, what do you guys think happens next? If you had to guess. You already know, because I kind of already explained it, but I just wanted to visualize it for you. No? Anyone?
Verifies the device.
Verifies the device. Kind of. So basically uses the access control engine that we were just talking about. So basically the access control engine does what we just explained. It takes all of that information, the request, the resource that it's trying to get at, the device certificate, the SSO, and it gathers all the information from the user DB and from the device DB, right? And it tries to make an educated guess as, should we let this happen or not, right? And what's really cool is like the amount of like technology that you can put on the access control engine to like make smart decisions about what people are able to have access to. And turns out Jim's an accurate employee and all of the things matched up. He's on Team A, I guess. So there we go. He gets access to the internal code service. And that's basically how it works, right? So what are the advantages to this, right? Like that's the 10,000-foot view of how BeyondCorp is structured in most corporations. And like if you went and read the Google white papers on it, that's basically what they say for the most part. And what are the advantages of it? Well, we did it. We're not relying on network perimeters for security anymore. We're basically having everything be public, and we're like, we have some kind of smart authentication mechanism that uses both the device that the user is connecting from and the user to verify whether this is a trusted connection or not, right? Which is a much better way of doing it. And another advantage, that you can use as a buzzword to promote this at your company someday is, hey, well, we allow users to work from anywhere in the world without a VPN now, which is, improving developer velocity. Got to have that. And fine-grained programmatic control over services and resources. So basically, it's very easy for us from a centralized point to say, this user has access to these things on these services, right? And it's super easy to define. And the main thing, the reason that we want to do this is from a security perspective, is it makes it a lot more difficult for attackers. Like, this is red teaming. This would not be as fun, or maybe be more fun because it'd be more challenging, I guess. So basically, like some of the requirements when you think about this, right? When we think about the model that we just exhibited, what you need is that device certificate. You can't authenticate to anything without it. You can't even like route to anything without it, right? And so the way to get the device certificate is you either gotta, go through the physical device. So let's say I have like a browser pivot or something on your laptop. That would be a way to bypass that. Or you need to steal a device certificate from the TPM or have some way to already have had the device certificate because maybe you've compromised like the certificate authority. And there's a bunch of PKI stuff that goes into that we're gonna kind of breeze over for right now. But so that's one requirement is you have to have the certificate somehow. Number two, you need to authenticate as the device owner usually, right? So basically we're restricting what user from what device. And that's really important. So we're basically saying if it's not the device owner that's authenticating, get out of here. So say you got some credentials from an online database on the dark web or whatever, and you're just like, finally, I can hack coolsite.com. That's exciting. So you go over and you're like, Jim works at coolsite.com, and I know he leaves his laptop open on Wednesdays while he's walking his dog, so I'll just sneak into his apartment maybe and get on his laptop and log in, right? You can't do that unless it's Jim's credentials, right? So that prevents that entire threat vector. That's not possible. And another thing, another advantage to it is you can have more sanity checks on usage, right? So basically we can say, Jim's mostly a developer. He likes to contribute lots of high impact code. That's just what he does. We pay him a lot for it. Why is he all of a sudden looking at all this HR stuff? Why is he trying to learn more about someone in the finance department? Like that doesn't make much sense. And you can flag that for security. You mean like maybe someone's trying to get more information about the organization to pivot. Which basically leads to the next point of it's easier to detect abnormal usage, right? Because it's a lot easier to monitor the normal usage of what's going on in the environment. Now you have some visibility into that, which is a huge like abstract portion of security is getting visibility into the situation. Now you can detect what's going on. You have an idea of what's normal, what's not, and you can implement some solutions there. Also, you can improve the response time. So let's say we knew that Jim's laptop was hacked. Let's say there's some vuln that came out and our security tools were like, whoa, this guy's running some not so bueno stuff. Well, it's really easy to revoke his access. So we can either, first of all, have those policies in place where we're like, no known vulnerabilities can already be on the device, right? Or number two, we can just revoke his certificate. We can be like, hey, this certificate's no longer valid, and he won't be able to connect. So that's the gist of BeyondCorp overall. Do we have any questions? It's a lot of stuff, but I think it's pretty cool. So, questions, concerns? Ben?
So if I wanted to set this up, how would I go about it?
How would you go about it?
Hard to do.
Like one person?
Yeah.
Okay.
Is there like publicly available tools, or are they all in-house?
So it depends. So Google Cloud actually supports BeyondCorp. Like they'll help you do it, but I don't know if it's something you could really easily do as a single person. It'd be kind of hard.
It's a lot of work.
Joe?
It's kind of like, in my opinion, setting up Duo, two-factor corporate stuff for yourself. It's like, yeah, you might be able to do it, but you're not really getting much benefit because you're just securing your own logins to the Duo admin panel.
Yeah, I mean, so
Stuff
like,
that.
I guess like a better answer for me is like you want 2FA. You wouldn't want to set up your own Duo, right? Like is what you're getting at, I think.
Yeah.
Don't set up your own Duo. Don't do that. Okay, cool. But you want 2FA still, right? The problem with BeyondCorp is like the whole point is to design for corporations to like scale their security because it just wasn't working, right? Like the whole point is that small like security networks might be fine, but when you get to a certain like point where you've just got all the stuff flying everywhere and it's impossible to manage, you need a better security posture. So that's the whole point.
I guess like the closest parallel you could do is like if you have a bunch of infrastructure that you use for projects, you could secure those that way, maybe. That'd be
Yeah,
one
I mean,
to do.
like the hard part would be like all the TPM stuff you got to do, and there's just a lot of components here, so it'd not be easy to do on your own, but you could definitely try. In the back.
Do you know if this is like a widely used thing right now? Like, is it starting to be widely used or?
So Google started it in 2011, right? So it's been around for a little while. People kind of know about it. 2014 it became public, so that's when I guess the rest of companies pretty much figured out what it was. And at that point, so you got to remember like a lot of companies that don't have like the resources for security that Google or other like large companies might have, it's a lot harder for them to like move to implement this sort of thing because they're just way far behind and they're implementing like a lot of other really important stuff. So that's just where their time is dedicated. But I imagine like as the security industry grows, it'd probably become more popular unless another better model comes out. But I can see things moving this way in like the next 10 years or so. Yeah. Tony, you have a question?
Sure. Can you go back to your topology diagram? Like
Which one?
slides ago? Right there.
This one.
So between endpoint and access proxy and access proxy back to ACE,
Hold on.
what are they talking there?
this to this to this.
Arrow, what protocol is that arrow? What are they doing?
That definitely is like just implementation.
Okay.
I don't know. Google probably has some kind of message broking service internally that they use, I imagine. So.
Protobufs.
Protobufs. That's what they're using. It's protobufs.
That's public.
Cool.
Yeah.
What I'm getting at is there's no like open standard that anybody can take and implement for languages spoken here.
I don't think so. So I don't know if there's any open source solutions to this yet. Like I don't know like if there are any access control engines even that are open source. I know Google offers it as a service. I'm not sure if Amazon does as well. But I don't know.
This looks a lot like what a bunch of companies have tried to do with Radius to incredible failure. Like,
Really?
Cisco's ICE is like exactly what you're describing, but it's Radius, so it's a dumpster fire. But in theory, it's cool. So I was just
Right.
like,
Yeah, there's definitely like I guess some performance related issues, right? Like that would be the main concern, obviously. Is like if you've got a huge employee base, say like 50,000 people or so, and they're all trying to access all these different tools, like you're gonna have a lot of load coming to this, and this portion here, the access control engine, could take a lot of time. So I'm not really sure how they do. I think so. A lot of it probably involves caching, to be honest. Like they probably just cache a lot of the access control stuff and then update it as frequently as possible, but that way it doesn't slow down the requests. That's what I imagine is the case. So cool. Other questions? On that side of the room, it's been very quiet. Anything? No.
They're just paying attention.
Cool, man. Well, I hope everyone enjoyed. I don't know if this is the last presentation or not, but real quick, huge shout out to like everyone that came and the e-board especially. Like this is like a 4-hour ordeal for like everything, which seems like a lot, and it's a lot for you guys to take the time out of your day to come here and sit through like the whole thing and learn for 4 hours. Like that's overwhelming for the most part. But like the e-board people, they had to be here for the entire 4 hours, and then they spent an entire summer setting it all up. So like they put in a lot of work. So thank you guys so much. Cool. Yeah, I'll be around at the barbecue if anyone has any other questions or just want to talk.
Thank you, Senor Corretto.
So, since we have a little bit of time, there is going to be a spontaneous presentation. It's not going to be streamed, however, but there is going. I need to be able to. I need a dongle, but I need the dongle.
Oh.
Okay. So what I'm gonna do is the stream off. You just turn it off real quick.